Hello everyone, welcome to my channel on data analytics. I am your host, Professor Rage Uday Kiran. In this video, we are going to learn how to visualize the results generated by a pattern mining algorithm available in PAMI library. The outline of this video is as follows. First, we will briefly look at the inputs and outputs of a pattern mining algorithm that exists in the PAMI library. Next, we will look at the various formats in which the user can view the results generated by a algorithm. Next, we look at the pseudocode to create the visualization results, and finally we will look at the demo. Coming to the inputs and outputs of a pattern mining algorithm, the algorithms in PAMI accept the input data as a file or a data frame or an URL where a particular file exists. In addition to data, it will also consider the algorithmic specific constraints such as minimum support, top K, etc. So, given these inputs, the any algorithm in PAMI will output the patterns, and then it will also display the total runtime taken to generate the patterns and the memory consumed during the memory process. Now, coming to the formats to visualize the results, we have various formats in which user can visualize the results. The basic one is the generated results can be stored in the data frame. This data frame can be later used for drawing graphs such as using Matplotlib or some other visualization software. In addition, the results stored in the data frame can be saved as a CSV file. Most important, if you want to use the results generated by any pattern mining algorithm in your research paper, then you may need the data in a latex format. The algorithms in PAMI also support the visualization of results in latex. Now, let us see how we can visualize the results using the pseudocode. So, in the pseudocode, we have two experiments. The first experiment, what we are going to do is, we will take the data set, we will extract the patterns at a single constraint value. So, we will only know the total number of patterns generated at a particular constraint value, how much memory it has consumed, and how much runtime it has taken. In the next experiment, we generalize it. So, in the second experiment, for a particular algorithm on a data set, we try to vary the minimum support values and generate the various patterns and store their memory and runtime requirements. These results later we try to visualize. So let us look at the first one. The first one is implementation on a data set at a single constraint value. So here what we are going to do is, first we are going to use the algorithm that exists in the PAMI library. Once we imported this algorithm, we initialize this algorithm with the necessary input parameters. Then we start the mining process and extract the patterns. The generated patterns will be saved in a particular file. Once we have generated the patterns and saved them, what we will do is we get the patterns into a data frame, and then we can print the total number of patterns generated in this process. Next, we can also look at the memory consumed by the mining process. For example, if we want to look at the total USS memory consumed, simply call get memory USS function that will print the total amount of USS memory consumed. Similarly, if you want to look at the RSS memory consumed by the pattern mining algorithm, please use the function get memory RSS. Generally, please keep in mind that we do not print both the memory requirements. We either choose USS memory requirements or RSS memory requirements to print the results in our research or daily work. And finally, using get runtime, we can measure the total time taken by our algorithm. So here is the example of how to use the algorithms in PAMI for knowledge discovery purposes. Please pause this video here and see step by step how the pseudocode and the example exist. Now we will look at how we can generate the results at multiple constraint values and use them for our research purposes. In the previous case, we have used only single minimum or single constraint to find frequent or interesting patterns. In this experiment, we are going to vary the constraint value multiple times, and at different constraint values we extract the patterns, memory consumed and the runtime consumed by the mining process. These results will be visualized as graphs. So the steps are as follows. First, import any algorithm that is of interesting to you. Then name the algorithm as a variable. Next, create a pandas data frame that will store the name of the algorithm to use, what are its input parameters, then the patterns, the runtime and the memory. Please specify these labels as the columns to the data frame. Next, for a specific constraint, please specify different values. Next, for each constraint, we call the algorithm and execute it. The generated results will be stored in the resultant data frame. Once we store the results in the data frame, we can print this data frame or store this data frame as a CSV file, or we can visualize the data frame using the library that exists in the PAMI repository. For example, if you want to view the results as line plots, simply call the function pami.extras.graph import data frame into figures. So this live PAMI program will read the data frame and it will print the results. Similarly, if anyone wants to view the latex code that can be generated for this frame, please go to this PAMI extras.graph. Here, instead of seeing the data frame and the results, please use generate latex file from data frame and input the data frame here and save it as a file. This file you can use it in the latex. Here is the small code on how to use a algorithm on a data set at different values. Here we are using FP growth algorithm at different minimum support values. So you can see at each minimum support value, I am executing the FP growth algorithm and getting the results. These results, I am storing it in the results data frame. This data frame will later be visualized by us using the data frame into figures program that exists in the extras folder of PAMI library. Please pause and carefully analyze the structure of this program. We will now look at the demo of how we can visualize the algorithms that are available in the PAMI library. For demonstration purposes, let us use Google Colab. First, let us install the latest version of PAMI library. Once the PAMI library is installed, please download any dataset from FIMI repository. So this is well-known frequent item set mining repository where there are several datasets. So this is one dataset which is very famous. So instead let us copy link address, download it here. So now we have downloaded the file. Let us print the T10i4D100K. Okay, so we can see here these are the items that are separated by space. Now for this synthetic data set, let us apply frequent pattern mining algorithm and try to discover the patterns from it. So in this case, we are doing the experiment 1 where we are going to use single minimum support. So step 1, first PAMI dot. The type of pattern we are going to extract is frequent pattern. I want to find all the patterns, so it is basic. Import. What are the available algorithms? You can see the list here. I'm going to use FP growth as algorithm. So this is my algorithm. In the next step, I'm going to create an object. for this algorithm. FP growth. Once you come here, you can see the parameters. First parameter is the file name. Next is the minimum support value that we plan to use, and then the separator. So our file name is T10 I4D100K. So first let us specify the parameter. Then we have to specify the minimum support. So let us say a pattern is interesting to us if it occurred at least 100 times in the database. Next, the default separator that we are using in PAMI is tab space. However, there is a simple space as the default separator. So let us rewrite our default separator and execute the code. Now let us do the mining process, which will try to find all the frequent patterns that have appeared at least 50 for at least 100 times in the T10 I4 D100K dataset. This process may take some time, so please wait for a while. Once we have generated the patterns, we can save them in a file. So let us say these are frequent patterns generated at 100 minimum support for T10 dataset.txt. So using this file notation, we have saved the file. So let us print the file to check whether it exists or not. Yeah, you can see the patterns are generated and they exist now. Now what we have to do is we want to know the statistics, like how many patterns have generated, how much memory consumed, and how much runtime it took. To know the total number of patterns that got generated, we can simply use the Linux command word count wc to check it. So let us use wc total number of lines in this file. So this will tell us that we have generated 27,532 number of frequent patterns. Now let us see the total runtime taken by the mining algorithm. obj dot get runtime. So you can see it took 15 milliseconds for mining process. Similarly, if we want to print the memory requirements, let us say memory uss, that also we can print it using obj dot get memory access. So this is the amount of memory consumed by the mining algorithm in bytes. You can divide it into different numbers and convert it into kilobytes, megabytes, gigabytes, and so on. So this is the process of generating patterns with a single minimum support value and use them. So here we cannot create graphs because we have discovered patterns with only one minimum support value. If we vary the minimum support values, then we can create the graphs. So that topic we are going to see now. So let us import the FP growth algorithm for pattern mining purpose. Once we have this algorithm, now let us create a pandas data frame. So here I am creating a pandas data frame called result, which will store the results of this experiment. So for this data frame, I am going to use the columns. The first algorithm is the name of the algorithm, which in my case is FP growth. The next one is the minimum support constraint. Next, I'm going to generate patterns. This is the runtime. So is the memory. So let us print this data frame. Okay. So we have this result data frame with 5 columns, and we already have the algorithm. Now let us create a minimum support list that will have different values. Now we have created a minimum support list with multiple minimum supports. So at each minimum support, we try to extract the patterns and see how the FP growth algorithm is working. So now we have created the list. Now what we do is using for loop, let us execute the code again and again. Let us say create an object, let us use obj1, that is algorithm dot fp growth. The name of the dataset is T10 I4 D100K dot dat. Next, the threshold value is mean support. Next, separator. The separator for this dataset is the tab space. Now, once we initialize this, we have to start the mining process. Once we have mined the patterns, we have to store the results in the data frame. So to do it, let us use the result data frame where we will store. So result dot shape is 0. So in this data frame, we are going to store the results. So the algorithm name is FP growth. Minimum support is the constraint that we have used. Then let us store the patterns that have generated. So obj dot get patterns. Sorry. So this will give us the patterns. Next one is the runtime. So obj1 one dot get runtime. Let us use USS memory and repeat it. So now let us do this mining process. Since we are running the frequent pattern mining at different minimum support values, the algorithm execution may take time. So please wait until we get the results. Once we get the results, we can see the text appeared. So this text will tell that frequent pattern mining has completed for a particular minimum support value. So now we have completed for two minimum support values, that is 400 and 500. Now we are working on 600. Now 3 years over. So now we are working at 700 minimum support. Similarly, we will complete 800. Once we complete the mining process, we can print the data frame. Yeah, mining process is over. Let us print the data. So this is the data frame of our results. Now you can save this data frame as a CSV file, or we can plot the results also, which is quite simple. Let us see how to plot this data frame results. To plot the results, we have to go to PAMI.extras. Since we are going to draw graphs, let us say graphs, import, you can see data frame to figures as fig. So we have created it. Now let us create equal to draw equal to fig dot data frame dot figures. So here we can give result and simply you say draw dot plots. This function has drawn the plot for the data frame. So this way we can create multiple plots for various attributes that exist in this result data frame. Thank you very much for viewing our video. If you liked our software, please subscribe to our channel for more interesting updates. Thank you.